This is part 6 of the Craftsman Emerson 150 drill press rebuild series. If you haven't seen part 5, click the link at the top of the screen. In this video, we will be cleaning up some used parts that we got off of eBay and then wire wheeling a whole bunch of parts. Hello everyone, I'm Jeff and welcome to my shop. We got a lot to cover, so let's get to it. Okay, so this is the Quill spindle assembly that I got off of eBay. It came with that feed stop bracket. We're just going to remove the nut and screw and lock washer that hold that feed stop bracket on there and remove it. It also came with that chuck you can see under it. And I think we're going to use all of these parts on this drill press rebuild except for that feed stop bracket. I'm probably going to hang on to that. So the chuck looks pretty good. All right, so we need to remove the spindle collar, and that has a cone point set screw in it that holds it in place. And I need the proper Allen wrench. I think it's a 5/32 to get that set screw out of there. Then that collar should just slide right off, but it's not sliding off. So, of course, over at the vise, we're going to use a flat tip screwdriver to kind of pry it off of there. There we go. And it still will not just slide right off. And it hit me in the face. In my face. All right, so there's your rubber washer. There's the metal washer or shim. And next we're going to drive the spindle through the bearings. And the rubber dead blow hammer is not even budging it. So we move to a brass dead blow, and my brass dead blow hammer explodes on me. So we go to a solid brass hammer. And then a punch. And yeah. So what's happened here is I've managed to mushroom the splines. I don't know if you can make that out or not. They're all mushroomed out by like 1/16 of an inch. So it's not coming through that bearing no matter what we do until we get rid of the mushrooming. Now, this is all at the very end of the spindle, so it's not a huge problem. So I'm just going to use a file to file down that mushrooming. But this also means that we're going to have to do a lot of work on this end of the spindle to clean it up. But to get it off of the bearings, we just need to file that outside circumference down. And the reason why it's not a big problem is because the spindle pulley assembly slides onto the spindle, interlocks with those splines, and its working area is the length of the splined area. So it doesn't have to have a perfect mating, if you will, at the very top of the spindle. We just need to get it so that the spindle pulley assembly will slide down onto the spindle. And then, as long as the splines are good for the rest of the splined area, it'll work just fine. So here we're just using a brass punch to push it the rest of the way through that bearing. There we go. And the splines look fine, so we just need to pump that other bearing out of the quill. And since we've already boogered the end of the spindle, no big deal. So here I'm using a caliper because I'm wondering why the hell these bearings were so hard to get off of this thing. There's something going on here. So I measure them, and these are special bore bearings. They should be 5/8 of an inch. and they are in fact 5/8. And the spindle itself is in fact 5/8. So I figured out what was going on a little bit later, but we'll talk about that when we get around to it. All right, so next we just need to get the spindle out of the other bearing, or get the other bearing off of the spindle. So we'll drive it through kind of like we did before. And it wasn't as hard as the other one, but it wasn't easy either. And I've literally had spindles and bearings that just slide on by hand. So I guess a tight fitting bearing is a good thing, but these are just way, way, way too tight fitting. All right, so like I said, we've got some work to do. I have covered the end of the spindle with Sharpie, and here we're just going to file down all of the splines and the edges of the splines. And I'm basically going to bevel everything. And we'll speed this footage up. But basically, as long as I can get it flush with the rest of the spindle or beveled below that, it'll be fine. And we're only working with like the top, I don't know, 3/16 of an inch of the spindle. So it's not the end of the world. It's not ideal, but it's not the end of the world. So I'm just using a straight file. I think it's probably like, I don't know, 3/16 of an inch thick. So it's kind of fitting in between those splines really good. And then I'm angling it to take down the walls of the splines a little bit. And the Sharpie, I did that so that I can see what I'm removing. So we'll try to test fit the spindle pulley assembly. I don't have it lined up very well, but there's still some binding going on there. So if you think about it, with splines, you've got several surfaces that have to meet. And there's a total of 6 splines, so that's 3 times 6, 18, and then so 24 different areas that are mating with that spindle pulley assembly. That have to get filed down and beveled. All right, so I think we've got it going here, and once it's on there, it slides just fine. Make sure that it's not misshaped and only lining up with certain lands and grooves or splines, if you will. But I think it's going to be fine once it's got some lubrication on it. Worst case scenario, if we have to, when we get to assembly, we can do some more filing. But I think we're golden. So all that work, my fault for beating the living heck out of that spindle. But I didn't see another way to get it apart, really. Probably could have soaked it maybe, but I don't know. I don't know why all of that was really hard to disassemble. Well, I do now, but I didn't at the time. All right, so the Jacob's chuck, we're going to disassemble it. So we've got the jaws protruding on the end of the chuck by about 1/2 inch, and we've got a socket that's sitting on there to protect those jaws. And then we're just using a sleeve from another Jacob's chuck to push the sleeve on this chuck to the left as we're looking at it. And if you want to really know how to disassemble and assemble and clean and lube and all that stuff, Jacobs chucks, I've got an entire video called the Jacobs Chuck Omnibus. I'll put a link for it here, and you can watch all of that in that video and see how it's all done. All right, so it's almost there, but it's not quite there. We need that sleeve to come down about another 1/8 of an inch. And I think that sleeve is hanging up. So we're going to grab the sleeve from the Jacobs chuck that came with this drill press that's in really bad condition and use it. And there we go. That's all we needed right there. So now we should be able to pull the sleeve off of the chuck. And then you've got your split nut, which normally falls apart right here, but it's not. There's hardly any lubrication on this chuck, so I'm going to need to use a flat tip screwdriver to kind of break open that split nut on the seam. There we go. 2 halves of the split nut. And then all we've got left are these 3 jaws, and they'll come about halfway out, but they won't come the rest of the way. I'm going to have to use a punch to push them. And probably a hammer to tap them. You'll see that one just kind of come out of there. There we go. So these jaws are in really good condition. The jaw face is nice and flat. No gouges in it or anything. So we'll do that for the other 2 jaws. And that's the chuck. So we're going to put all this stuff in a plastic bin, and then we're going to soak it in simple green for 24 hours. I'm not worried about derusting. There isn't a whole lot of rust on this stuff. We just want to remove any grease or oil that's on there. All right, so this is the rest of this video. I'm telling you right now. We have the motor mount, and it is heavily rusted and heavily pitted. This is after derusting. And I spent a couple of hours really just running all the parts through this brass wire wheel on my grinder. So there's some areas on this motor mount that I can't get to with this wire wheel. You can see how bad the backside of it is. It's ridiculous. But it is what it is, and we've got to work with what we've got. So I was hoping that wire wheel would take a lot of that pitting out, but nope. All right, so here I'm just going to clamp it to the table and hit it with this wire wheel in the corner areas where I couldn't get to the that area with the grinder wire wheel. But you can see how bad the pitting is. It's horrible. And the paint that I'm going to use is not a hammered finish paint, so I don't know how bad this pitting is going to show through the paint. And you look at that right side of that motor mount. That thing is horrendous. Maybe the primer will fill in some of the pitting, but I think we're just going to have to roll with what we got. All right, so this is the air cone for the motor. And the motor did not come with this drill press. It's a different motor that I had, so it's not pitted or in super bad shape. And that is the terminal cover from the motor. So these motor parts cleaned up just fine. Just like a normal drill press that I rebuild. And that's the capacitor cover. All right, so these are the rods for the motor mount. And they're pitted as well. But the outside circumference of them is not a critical size, so we can sand those and get them down. And these are the through bolts, through screws, or long screws, whatever you want to call them, for the motor. There's 4 of them. And that's the chuck key. I'm probably going to just replace that thing because it is pitted really bad. And then a couple of other parts, retaining rings and screws and whatnot. But like I said, everything, pretty much every part on this drill press is going to have to get this wire wheel. These are the feed handle rods, and they are pitted as well. Again, not a critical outside diameter, so we're going to be able to sand those. So here I'm just taking some bottle brushes, and I'm going to clean out the bores in all these parts. Anything that has a bore in it, I'm cleaning it out. These are your various sleeves and locks for the table and the head. It's the chuck. And this is where I figured out what was going on with the spindle collar and the bearings. So the previous owner of that Quill spindle assembly had put bearing compound on the spindle collar and the bearings, and that's why they were so hard to get off. But yeah. So I think the last thing there is just those bearing bores in the Quill. I'm just going to lightly clean them. Don't want to take any metal with us. All right, back over at the grinder. These are the lock handles for the head and the table. And they are also heavily pitted. However, I don't see a way to really get rid of that pitting other than to hand sand them. So I think we're just going to leave them pitted, and they'll have that texture. They kind of look like they've been pebble blasted. but I can't chuck them in a lathe and sand them that way because they're bent. So then we've got the various sleeves and locks that we're just going to screw onto those handles and clean them up. And these sleeves and locks are pretty pitted as well, but I think they're going to slide okay. We might do some sanding on the outside of them a little bit, but for the most part, I think we're going to go with what we got. Now, there's two different versions of these for all of your Craftsman drill presses. There's the hardened steel ones, and then there is some Zamek lock nuts and sleeves. And the Zamek ones will deform over time because it's a softer metal. These are the hardened steel ones. So here is the spindle, and we're just going to clean up the splined area with this wire wheel. The rest of the spindle will clean inside the metal lathe. We'll wet sand it, but yeah. Then we've got the pinion, which also is pitted, kind of in the gap area between the two bores that it sits in. So it really probably won't even affect it, but doesn't look great. That's your sleeve that goes, sleeve spacer that goes between the two bearings on the spindle pulley assembly. That's one of the retaining rings. And then these are the the felt covers and bearing caps for the motor. And they cleaned up just fine. And this is the spindle collar. And we're just cleaning up the outside of it. And then these are the two halves of the half nut, or the split nut for the Jacob's chuck. And then you've got the jaws. My grinder keeps trying to walk away from me. And then there's the sleeve for the Jacob's chuck. We're not going to clean the Jacob's chuck body in the wire wheel here because it's got a lot of sharp edges on it, and that wire wheel will just grab it and sling it. So we'll tackle that in the next video. And I'm just using a vice grip to hold some of these smaller screws and whatnot, clean them up. But pretty much every part for this drill press had to go through the wire wheel. Yep, that's going to wrap up this video. I'm sorry that that we had the 2-week hiatus there, but we had to wait for some parts to come in and get some other things squared away. But we're back on the project, and another video next week. So I hope you liked this video. If you did, please like and subscribe. I appreciate all the support, and as always, I will see you next time.